practicing Algebra 2 by now, so you're in luck because I have this awesome Algebra 2 recording for you guys. I hope everybody's doing well when you're listening to this. So, this recording is for section 4.1 in your book. We're starting a new chapter, and we're going to be talking about quadratic equations. So, actually, up until this point, if you think about all the math that we've done, we have talked a lot, especially in the last chapter 3, about linear equations and solving linear equations and, making linear equations into matrices and all kinds of great things like that. And now we are actually going to shift a little bit and we're going to talk about quadratic equations. So if you have your notes, pull them up. We are going to start at the top. So what is a quadratic equation? What does it look like? Switch back over to Paint here, and let's talk about what that means. So a quadratic equation has the form, and you can see it written there. Actually should have another value in front of that. It's of the form ax squared plus bx plus c, and then equals some y over here. Okay, and this is when a, b, and c just represent numbers, right? Generally, we'd like them to be whole numbers, but they just represent numbers. Really, our variables are our x squared and our x, and then we have our constant c down there. So what you notice when you see this equation, this quadratic equation, the difference between our linear equation that we did a ton of work on, which if you remember is y equals mx plus b. The difference between a linear and a quadratic, nope, that's a G, quadratic, is this x squared term. That's what makes it different. So when they define quadratic equations, you'll see ax squared plus bx plus c equals y, and a cannot equal 0. Because if a equals 0, then guess what? We just have a linear equation. So we study a lot of quadratic equations in Algebra 2. You might have done a little bit in Algebra 1 as well. They are kind of one of those fundamental equation types. And one of the things that's really important about quadratic equations is how they are graphed. So this is the standard form of quadratic equation. What makes it unique is this x squared term. If you have, for example, an x cubed term, then it's not a quadratic equation. This is called a cubic equation. So we'll get to those in a little bit. That is a thing. But really, we're just focusing in on those equations that have an x squared term. And sometimes you'll have an x, and sometimes you won't have an x squared. But you always have that x squared term in order to have a quadratic equation. So the first thing that I wanted to talk about is let's just kind of take it down to the simplest level. So this is our equation, but really what fundamentally makes it a quadratic equation is x squared. So we are going to flip over to Desmos, and we are going to strip away everything else, and we are just going to graph this most basic quadratic equation, which is y equals x squared. So you'll see there's just a 1 out front of the x squared, and b times x and c, we're going to take those off the table now. We're just going to go for the basic y equals x squared. This is the basic quadratic that we can compare everything else to. So let me flip to Desmos, and let's put this in a graph. So y equals x squared. And you see that before, when we just have y equals x, right, we have a line. That's our linear equation. But all of a sudden, we put this x squared term, and we get a fancy bowl, which we call in mathematical world a parabola. So the graph of a quadratic equation is a parabola. They're all going to be some form of a parabola. This one happens to open up. Some of them open down. Some of them are shifted around the graph, but this is kind of the basic form of a quadratic equation. So there's a couple things I want to point out. Let me print screen. This is our y equals x squared. Pull this up in Paint so I can draw on here. Okay, so there's two features. Oh, I thought my computer was turning there. There's two features that I want to point out on this graph that are important to parabolas. So whatever point, in this particular case, since this parabola opens up, this is down here is my lowest point of my parabola. That's the least value that I can get to. And this point has a specific name, and this is called the vertex. Okay, and you may have heard vertex before when you were referring to like corners of a polygon. But in a parabola, it's either the lowest point, or we might have a parabola that it's the highest point, and I'll show you what that looks like in a minute. The other feature that's important to note about quadratic equations is that quadratic equations, which I really like, are always symmetrical. Okay, so this particular quadratic equation is symmetrical about the y-axis. So if I draw my purple line here, this is my line of symmetry. If I fold my parabola in half, right, if I fold it over, it's going to be symmetrical. And that's true of all parabolas. They have this idea of symmetry. So this is the line of symmetry. Running out of room. There we go, line of symmetry. So those are kind of the two features of a quadratic equation when it graphs that I want you to take note of. Also, you might have noticed that the line of symmetry goes through the vertex. That is not an accident. So the fact that the line of symmetry goes through the vertex also always occurs. So wherever that vertex is, the highest or lowest point, the line of symmetry is going to go through that point. And on top of that, but wait, there's more, right? On top of this, if I want to figure out what value of x this is, there is a special formula to find what value of x we have for here. So what I mean by that is that we can find this x value by taking negative b over 2a, and this b and the a refer to my coefficients in my quadratic equation. All right, so if you recall, for this particular one, we have y equals x squared. But this refers to y equals ax squared plus bx plus c. Okay, so, excuse me, if I match up my a, my b, and my c, the b term here is 0. B is 0. So when I plug this into my little equation to find the x where my vertex and my line of symmetry are located at, I get 0 over some number. So this one happens to be at 0. That's kind of why we started off with the simplest case. All right, so that is kind of the basics of a parabola, or of a quadratic equation, that it's graphed as a parabola. So what I'd like to do, if you have your notes out, we're going to go through on your notes, but I think what would be helpful is if you have your graphing tool up, or you can open another tab, or pull up your, your TI, or put it on your phone, however that works. I think what's helpful is if you first do a little bit of playing with parabolas to kind of see how they react, to kind of get a feel for what does doing different things to my equation do. So I'm going to start with this basic y equals x squared, and I'm going to copy it. I'm going to graph it again. And what happens if I make this negative? All right, so the red is my original, the blue is my new one. I'm just going to turn that off for a minute. So this is what I was talking about, where sometimes your vertex is actually at the top of your parabola. So this particular parabola opens down, and my vertex is actually the highest point. So the vertex is usually either the lowest point or the highest point, and that all just depends on your leading coefficient here, if you have a negative or a positive number. The axis of symmetry, I think you can see pretty clearly here, is again, the y-axis is the axis of symmetry. Interesting side note, if you want to graph a parabola by hand, you typically will need 3 to 4 points to be able to do that. So you're going to want to find the vertex, right? And then you're going to want to find probably 1 or 2 other points that are along here, and then we can say that that's symmetrical along the other side. So that's just kind of one thing to note. Okay, so we will hide this graph. We'll go back to our standard graph here. Y equals x squared. And like I said, I think that even if you want to pause the video and do a little playing with Desmos, I think it's helpful to kind of see what happens. How does the parabola react to different parameters being changed? Okay, so what do I mean by that? I'm going to stick with my y equals x squared, but I am going to put a 6, y equals 6x squared. Okay, so let me close all the other ones. So you can see that my original parabola, my original quadratic, is y equals x squared, and this is y equals 6x squared. So what happens to my parabola when I put a coefficient of 6 out in front of the x squared? Well, the parabola just grows more quickly. It grows faster because I have a larger number. I'm multiplying everything by 6, right? So the larger my number here, so let's do like 20, the larger my number, the faster my parabola grows. All right, so then what do you think happens is if I put, instead of a whole number, if I put a fraction, so y equals 1/2 x squared. So now you see that my parabola is going a little bit slower. Right? And then if we get an even bigger fraction, oh, that doesn't even look like a parabola anymore. There we go, 1/10. Then my parabola is growing more slowly. It keeps that same parabolic shape, but the speed at which the parabola opens or closes depends on this leading coefficient. So you can play with that a little bit. All right, so we did that. Now let's go back to my y equals x squared. All right, and then what happens if I add plus 1? Okay, so I'm skipping over the x term and I'm going straight to just the c, the end of my quadratic, my constant. So if I add 1 at the end, you can see my parabola is the same. It actually just shifts the graph up by 1. And it's a little hard because the scale's off here. So there we go. You can see same parabola shifted up by 1. So then what do you think would happen if I copied, and again, play with this, right? And I subtract 1. So then my parabola remains the same, right? But it shifts down. Okay, so now let's add that x term in. Plus x. So this one's a little bit harder to interpret. So once we get to this term in here, then our vertex gets moved over. Okay, so we have, let me delete this, y equals x squared and y equals x squared plus x. So you see my two graphs here. We have something interesting because we no longer have a vertex that's along the y-axis. We have it that's off to the side. And let me try to get a little bit nice. Trying to get a nice mathematical one. That'll work. All right, so what I did is I have y equals x squared, and then I have y equals x squared plus 4x. So I am going to pull this off. You can see where, oh, before I do that, I'm going to put up where my vertex lie. And we will talk about how you can calculate that. Okay, so pull that over, open it up in Paint. All right, here we go. So here is that graph that we were just looking at, okay? And if you remember, I said that, well, the vertex is the highest or lowest point. So in this case, we have a vertex at 0, 0 for the red graph, and the vertex of the green graph, the one that we have the plus 4x, is at -2, -4, okay? So if we look at the red graph, we know our vertex is right here, and our axis of symmetry is right along here. It's pretty easy, right? If I go to my green graph, I know Desmos actually tells me where that's at. You can also use the trace feature of your TI if you have that. I know that my vertex is at -2, 4, and my line of symmetry is when x equals -2. That's where my line of symmetry lies for this. All right, and then this kind of pulls back in that equation where we were talking about that I can figure out where my x component of my vertex is and my line of symmetry with this little equation. So let's kind of step back. So we have ax squared plus bx plus c, okay? And we know that the axis of symmetry in the vertex, the x component, is when x equals -b over 2a. All right, and in this green equation right here, our a value is 1, and our b value is 4, because a is whatever is before x squared, and b is whatever is before x. So x equals -4 over 2 times 1. So our x value is -4 divided by 2, -2. Huh, look at that, works out. What we calculated on here is that our x value is at -2, and the line of symmetry is when x equals -2. The last little part is, well, Mrs. Ross, how do we get the -4 on the graph? How do we figure out where the other part of our vertex is at? Well, in order to do that, we have to look back at our original equation. So we know y equals x squared plus 4x. And we know the vertex is when x equals -2. So if we plug that in, the y value is -2 squared, which is going to be 4, plus 4 times -2, which is -8. So our y value is at -4, which is this value right here. So that's how you find the coordinates of the vertex. You find the x, and then you plug it in to find the y value. Okay. So I have a couple examples on the page. We're going to go through them pretty quickly because I think you guys will be able to catch on really fast. And then you'll be on your way to graphing quadratic equations. So let's clear that off and pop back over to your notes here. So we have graph the function, compare it to y equals x squared, label the vertex and the axis of symmetry. So this is pretty easy stuff. I'm not asking you to hand graph it, but I do think you should be able to find the vertex and axis of symmetry algebraically as well as graphically. Obviously, you can do that. So first we have y equals 5x squared. I think we've kind of covered that, so we're going to go ahead and let's tackle 2, 3, and 4. So we have y equals 4x squared plus 1. This looks actually similar to what we were just doing. We just flip-flopped our numbers. So we have 4x squared plus 1. Okay, so we have our original parabola is our red parabola, and our new parabola is our green parabola. You can see that the graph has been shifted up 1 unit, and that's due to this plus 1 at the end, right? It's also increasing a lot more quickly because our x squared term is multiplied by 4. So what I want you to find is the vertex of and axis of symmetry. This one is pretty easy to do, but let's do it algebraically, and then we'll go back in and double check our work, okay? So pop this over here. Here we go. All right, so we have y equals 4x squared plus 1. So in this case, our a term, the term that's before our x squared, is 4, and our b term is 0, right? Because there is no plus x. We can just say it's plus 0x. All right. So now when I go to find out where my vertex, the x of my vertex and my axis of symmetry is, it's negative b over 2a. Well, b is 0, so it doesn't really matter what 2a is, even though I know it's 8. My x component of my axis of symmetry is 0, which lines up with my graph, right? You guys saw that already. My x component is when x equals 0, which is basically my y-axis. All right, but what about the y component of my vertex? Well, I find that by taking my original equation, y equals 4x squared plus 1. And I know that the x part is 0. So when I plug that in, I get y equals 1. So I know that my vertex should be at 0, 1. And my axis of symmetry, I'm just going to write axis, should be at x equals 0. So when I go to my graph now, my vertex right here, you guys probably already saw, I clicked on it, is at 0, positive 1. And my axis of symmetry is when x equals 0. Okay. Now, if you have, so it all kind of matches up. If you have a TI calculator, it cannot graph x equals 0. I do believe, let's check that Desmos can graph x equals 0. So let's see, x equals 0. Yes, it can. So you can see here, I'll turn that off. Our axis of symmetry is x equals 0, and our vertex is at 0, 1. Okay, so let's do number 4, and then I think you guys should be ready to tackle this section. The homework is 7 through 31 odd. So let me get problem number 4, and then when we get back, if anyone wants to see more examples, I'm happy to do that. So number 4, we have f of x. I think we've talked about this in that class, but we haven't. Remember, this is just a fancy way of saying function. Yeah, we just talked about this. You just had a test. Fancy way of saying function, so you don't need to worry. We can just still treat this like y equals, right? Let's see if it'll let me copy it. Oh, that would be nice. Let's see if it'll let me copy it and put it in Desmos. Sort of. Sort of. There we go. Maybe. Okay. That makes me feel better that it's written like that. All right, so we have f of x equals 1/2 x squared plus x minus 3. And you can see we have a parabola. It's much bigger than my other parabola, and that is due to this half term. And before we click on it or look at the numbers, let's see if we can take this and we can figure out where this vertex and the axis of symmetry is algebraically, and then we'll double check it on the graph, okay? So in this particular case, we have our a, the term that is before x squared, is 1/2. Our b is 1, right? Because we just have a plain old x here. And c is negative 3. That is not important right now, but later on that will be important when we learn the quadratic equation. All right, so the x term of the axis, or the x term of our vertex and the axis of symmetry are at negative b over 2 times a. So negative 1 over 2 times 1/2. That works out nicely. 2 times 1/2 is 1, and negative 1 divided by 1 is just 1. So I know, now that I look at this, I see that my axis of symmetry is at x equals negative 1, okay? And that my vertex is at negative 1, and I don't know my y component, but I can figure it out pretty easily, right? Because I have an equation. So if I take my equation, my y term is at 1/2 x squared. So my x is negative 1 squared plus negative 1 plus negative 3. So Negative 1 squared is 1. So this is that 1/2 plus, and then we'll just go ahead and add negative 1 and negative 3, negative 4. So this would be y is at negative 3 and 1/2. Negative 3 and 1/2. All right, so I think my vertex is at negative 1, negative 3 and 1/2. So now you can use your graphing tool and double check your work. So if I click down here at my vertex, it is at negative 1 and negative 3 and 1/2. Yay, give yourself applause, right? And I said that my axis of symmetry is at x equals negative 1. And there we go. Nice and symmetrical about that. All right, so I think you guys should be able to rock the section 4.1. I will have another video for you to watch for 4.3. We are skipping over 4.2. So have a great day. Talk to you later.